talking to you. This is Goddess of Science Anatomy, and I'm Mrs. Bolden. Today we're going to talk about the bone remodeling process in part 3 of my skeletal system series. Okay, so last time we talked about how bone is laid down, and that's pretty easy to understand how that process happens. But you have to, there has to be a mechanism for you to remodel your bones throughout life. Just because you're grown and stopped, your epiphyseal plates have closed and now they're epiphyseal lines, doesn't necessarily mean that you aren't going to have small changes to your bones. If you have different stresses on your bones, you're going to need to remodel those, or there are going to be some serious issues that are happening. So bones are constantly changing through your life. Some parts of the bones are broken down, others are added to. It's just they're constantly changing. You can kind of think about it like a tide. The tide comes in, the tide goes out. We take a little sand from here, put it over there, so forth and so on. So the process to build a bone involves some hormones, and it's always a good day in anatomy to get to talk about hormones. The anterior pituitary gland that hangs from under the underside of your brain makes a hormone called growth hormone. So here's your brain. The hypothalamus is kind of the interface between the pituitary gland, which is where the hormones are stored and manufactured, and the brain. So this is kind of like the in-between. So the pituitary gland hangs off the bottom of your brain, and it has two lobes, and it kind of looks like brain testicles, believe it or not. So the growth hormone that's made by the anterior pituitary gland turns on the osteoblast. That's the signal that says, okay, we need to build some bones. Same signal when you were a little kid and you were going through a growth spurt. The growth hormone goes out there and turns on those osteoblasts and says that the osteoblast should be turning some of that cartilage into bone. So if you have excess calcium, which is called hypercalcemia, it's a good idea for your bones to store it for later, because you never know, particularly with women after menopause, when the estrogen train no longer stops at our station, you don't get a whole lot of that. So if you have extra calcium, it needs to be stored for later, because you never know. Calcium is really, really important when we talk about muscle contractions in the next chapter. Calcium is critical for muscle contractions, and there's no more critical muscle that needs calcium than your heart. Without your heart, you're not long for this world. So we got to make sure that we have calcium stored up just in case we go through a time when we don't have a whole lot of calcium. So growth hormone makes that happen. If a person's weight increases, the bones also increase with the increase in weight. So really, really important to realize that if you're going to move a bigger mass, you're going to need more muscle to do that. If you have bigger muscles to move a larger mass, then you're going to need bigger bones. Otherwise, if you had the bones of a ballerina and you were 350 pounds, it would be very easy for the muscles to actually snap those bones. So as your weight increases, you have more to carry around, and the bones are going to get larger as well. If the muscle size increases, that also, people who are weightlifters, they have a larger muscle mass. They'll have a larger bone mass as well, for the same reason. Because if you have a great big huge muscle, very powerful muscle on a very skinny thin bone, it's going to easily snap that bone. So the bigger muscles pull harder on the bone. That's going to cause it to increase in size. So To avoid breaking bones, you got to have bigger bones, which mean the osteoblasts are going to be working here. I love this picture because this is the before picture and this is the after picture. Exactly the same guy. Got a little steroid action going on here, I'm pretty sure. Huge muscles like that, going to need very, very large bone mass, thick, heavy bones to be able to support those muscles. So there are times when bone gets destroyed. And there's a hormone for that as well. It's called parathyroid hormone. It's made by the parathyroid gland. It's abbreviated PTH because parathyroid hormone is a little long to talk about. And I thought I had a little picture here, but apparently not. I'll just describe it. Your thyroid gland is kind of a butterfly that sits in the front of your trachea in your neck. And there are each wing of the butterfly, the four wings of the butterfly, has a tiny little gland on it called the parathyroid gland, and that activates the parathyroid gland, makes parathyroid hormone, which activates the osteoclast, and that breaks bone down. Why would parathyroid hormone want to break down? Oh, look, I do have a thing. Wants to break down bone. Hold on just a second. I want to go to this little diagram here. This is the front view here. So along the back, there are these four tiny little red dots. Those are the parathyroid glands. So if your blood calcium is too low, now I mentioned before that calcium is really important in muscle contraction, particularly in your cardiac muscle contraction. If you don't have enough calcium circulating around in your blood, then it's going to take it out of your bones so that your heart can continue to contract. So it takes it out of the bone. If you decrease in weight, your bone mass is also going to decrease as well. Because for the same reason that it increased when you gain weight, it decreases because you don't have as much to carry around. If you live in a zero gravity environment, gravity isn't pulling down on you. And so you don't have that force being exerted on your bones, so the bones start to break down. When the astronauts first went to space for any length of time, the Russians were the first ones that spent a long time in space. The cosmonauts, that's what they called them, came back to Earth after their time up there, and they were young men, but they literally had the bones of a 75-year-old woman, because they didn't understand that while they're in space, they're going to lose like a tremendous amount of bone mass because of there's no gravity pulling down on you that you have to constantly work against. Now you often see videos of the astronauts on the International Space Station, and they usually are doing some sort of exercise every day, stationary bike, something to move their muscles so that they don't have muscle atrophy and they don't have bone loss. And the other thing is, if you are bedridden, one of the things that you do, like if you're in a coma or something like that, even then they send people in to exercise, move your muscles so that you maintain bone mass and muscle mass. So being bedridden or in zero gravity environment, you decrease your weight, your blood calcium concentration is too low. Okay, well, that's it for this time. Thanks for joining me. Have a great day.